Hello everybody! If you've ever struggled with solving linear equations for your homework or SAT, you should know that there is a simple, systematic approach that works every time. What's also interesting is that this method has been used for more than 1,000 years, and it was one of the first clear, step-by-step solutions for a mathematical problem. It started in the city of Baghdad in present-day Iraq, and it was published in the first treatise of algebra by the man who actually named this discipline. I'm talking about Muhammad al-Khwarizmi and his calculation by restoration and balancing, aka Al-Kitab al-Jabr, which gave the name of algebra. Funnily enough, algebra was a medical technique for fixing misaligned bones, but its meaning was expanded to mean all sorts of fixes and rebalancing, including for equations. What Al-Khwarizmi understood by restoration and balancing is what we commonly do when we're solving linear equations. We're undoing how they were made. So an equation that contains an addition of a number will be solved by subtracting it, and if we encounter a multiplication, we just divide by that number. Here's what I mean. In the equation x plus 13 equals 25, you get to x by undoing the addition of 13, namely by subtracting it from both sides. Hence, x plus 13 minus 13 equals 25 minus 13, or x equals 12. For the equation 2x plus 12 equals 42, we undo the outer layer first, which is the addition, and we subtract 12 to get 2x plus 12 minus 12 equals 42 minus 12, or 2x equals 30, which got us closer to freeing the unknown x. It is now held closely by multiplication by 2, which we undo by dividing the equation by 2 to finally get 2x over 2 is 30 over 2, or x equals 15. This method was described more than 1,000 years ago, and it is still the basis for our linear equation solving. So to recap, what we'll be doing when solving our SAT problems is this, step by step. 1. Simplify both sides of the equation if necessary. 2. Get all variable terms on one side of the equation and all constant terms on the other side of the equation. And 3. Isolate the variable by dividing both sides of the equation by the coefficient of the variable. Now let's see how this works on some problems I selected from previous SAT exams. Problem 1. If 3 times 3x plus 5 equals 2x minus 8, what is the value of x? And you'll see here to the left we have 3 words in 3 different colors because those are the colors with which we are going to be identifying each of those terms, coefficients, variables, and constants. Alright, so to get us started, we first need to simplify, as it said in the first step. So 3 times 3x plus 5 equals 2x minus 8. We're going to simplify by removing the parentheses. So we're going to get 9x plus 15 equals 2x minus 8. Now here at this step, we're able to identify coefficients, variables, and constants. So for coefficients, we're going to start by writing 9 with green, x as a variable with black, and then 15 as a constant with blue. And then this will be equal to, once again, we have a coefficient, 2 times x minus another constant, 8. So now, as we had in our previous step, we are going to need to get all variable terms on one side of the equation and all constant terms on the other side of the equation. So in order to do that, we are going to remove this 15, and we're going to need to do that on both sides in order to keep the equation balanced. And we are going to also need to subtract by this 2x on both sides in order to keep the equation balanced. So what does that come out to? It comes out to 9 minus 2x, which is going to be 7x. This 15 cancels out, and then 7x will be equal to, this 2x also cancels out, it will be negative 23. And actually, let me write that in blue since it's a constant, negative 23. All right. So now we are going to do step 3, which is isolate the variable by dividing both sides of the equation by the coefficient of the variable. The coefficient in green, we see that it is 7. So we are going to divide both sides by 7, and this is going to give us x equals negative 23 over 7. We go back up to the responses, and we see that that is indeed one of them. So A is the correct one. And now we're going to be moving on to problem 2. It says that y equals 1 over 2 times x plus 3 and y equals x plus 1. And then given that, we need to find out x. In order to do that, we need to set an equality sign between the two equations. So that will be 1 over 2 times x plus 3 equals x plus 1. Again, we're going to make sure that now we have our coefficients, variables, and constants. So that will be 1 over 2 times x plus 3 equals x plus 1. There's not necessarily any simplification to do, so we can go straight to step number 2, which is getting all variable terms on one side of the equation and all constant terms on the other side of the equation. So doing that will get us, we will subtract by 3 on both sides, and then we will subtract by x on both sides. So what will this get us? This will get us negative 1 over 2 times x. This 3 cancels out, will be equal to, this x is going to cancel out, and it will give us 1 minus 3, which is going to be negative 2. Now, step number 3 tells us isolate the variable by dividing both sides of the equation by the coefficient of the variable. The coefficient of the variable is negative 1 over 2, so we're going to divide by negative 1 over 2. So from here, we are going to get x, because this cancels out, equals negative 2 over negative 1 over 2. This negative will cancel out, so this will be 4. So now we have x equals 4. Another way to solve this problem would be graphically, and so we're going to do that in this next step. I'm going to rewrite my equations just to make sure that I have them accessible. So y is 1 over 2 times x plus 3. Y is x plus 1. And so what we're going to do for us to graphically represent these is that we're going to need to find some coordinates that match our equations. In order to do that, I'm going to take different values of x and different values of y and see how they match up. For the first one, for the first equation, we will have this table, x and y, and I'm going to take 2 values each. However, I see that x is divided by 2, and so we're going to need an even x to make our values be a little easier to draw. So I'm going to choose 0 and 2 for x. For x is 0, y is going to be 1 over 2 times x plus 3, so 1 over 2 times 0 plus 3, so that will be 0 plus 3, which is 3. For x equals 2, y is going to be 1 over 2 times 2 plus 3, so 1 over 2 times 2 is 1, so that'll be 1 plus 3, which is going to be 4. Now for the second one, which is y equals x plus 1, we're going to draw a similar table. This time we're just going to do it for 0 and 1 because we don't see any special coefficient in front of x. And so x plus 1, 0 plus 1 is literally going to be 1, 1 plus 1 is going to be 2. And so these are our values. I'm going to draw them with 2 different colors, let's say green and blue. And so for the first one, let's make the first one green. X is 0, y is 3, so x, this is the x-axis, this is the y-axis, x is 0, y is 3, so this is where our first one is going to be. And x is 2, y is 4, this is where our second one is going to be. Now what I need to do is draw a line in between these 2 points, and I'm going to take out my line and draw it. And I'm going to do something very similar for 2. X is 0, y is 1, so x is 0, y is 1 will be over here. And x is 1, y is 2 is going to be over here. And I'm going to once again get my line and draw it. And we see that the intersection between the 2 points is here. And that point is x equals 4. X equals 4, we see checks out to the previous x, and so we have the correct number. Now for the final problem, we have a word year problem, so we're probably going to have to translate this from English into math. Let's take a look. Jamila plans to invest $300 by buying shares of two different stocks. Stock A costs $5.62 per share, and stock B costs $12.97 per share. Which equation represents the number of shares of these stocks Jamila can buy, where A is the number of shares of stock A, and B is the number of shares of stock B, assumed that there are no fees. So one of the first steps that we're going to take is identifying the coefficients, variables, and constants. If we take a look at the last sentence, we see that we are given that A is the number of shares of stock A, and B is the number of shares of stock B. So this tells us that A and B are our two variables. Now, what do we know about these two variables? If we take a look at the sentence before that, we see that stock A costs $5.62 per share, and stock B costs $12.97 per share. So these are our two coefficients, 562 and 1297. As far as the operation between them is concerned, we are told that Jamila plans to invest $300 by buying shares of two different stocks. So this insinuates then that if we're buying the shares of two different stocks, the operation would be addition, and it would equal to $300. So let's write this out in a more math way. We would have 5.62 times A plus, we're going to take the other coefficient, 12.97, this time times B, equals $300. So we're going to cross-reference what we got with the answers above, and we are going to see that one of them corresponds exactly to it. And there you go. These have been our problems today. Thank you so much for tuning in. Please make sure to drop a like and comment for any other video ideas that you might have. And we're going to welcome you over to our website and Instagram. Make sure you follow us over there in order to see similar content. Thank you so much, and we'll see you in the next one.